Okay, last but not least, I want to talk about facing. So here we have our part, and I'm going to use a 1 1/4 inch end mill to face this part. Okay, I'm just going to draw it for you just so you can see how big the tool is in relationship to everything. Just draw a circle and then click on your diameter, proportions, and go 1.25 and hit enter. Alright, so that just shows you how big the diameter of the tool I'm planning to face with. Now with a tool this big, you definitely do not want to plunge directly into the part. You want to face this off, but you want to mill it. You don't want to plunge cut at all with a big facing mill, okay? So what I've done here is I've drawn a line that will keep that tool off the part. So I'm going to go from my home position to a position which will actually be up here relative to this line. The operation to do this is going to be a profile cut. We're going to profile along this line, okay? So it depends on how you have drawn the line. So when I drew this line, I drew it like this. Select the line, I went to this point and dragged it out to here, to the end of that, and hit enter. Okay, I'm not going to do that because I already draw it. It's not a big deal to draw a line, okay? But if I drew the line from left to right, it would have an impact on how the thing would be machined, and that's what you need to know. Okay, I just wanted you to understand that. So when I generate the tool, let's just go through the parameters of the tool path itself. First, obviously, you have to enter a tool diameter for this because it uses a step over and offsets for the tool. So our step over is going to be 40% of the tool, 0.4 in this case. That's what you call it. 0.4 is 40%, okay? That's how you call it. Now my cut width is going to be 6.25 inches, 6 1/4. So 6 1/4 away from this is my overall cut width, okay? And it's going to step in increments and step over at 40% of the tool. So it's going to go out to here 6 1/4 inches and then come in at 40% of the tool at a time till it finally reaches this line over here. And that's the wall that it's going to end up on. Alright. Then you got inside and outside. This is going to depend on which side of this line it's going to cut. Okay, so that's an important thing to understand as well. I set my clearance plane to 0.1 of an inch, which I typically do. The feed rate is arbitrary in this instance. I could probably go about 90 inches per minute with this, which I did. And my depth of cut is a 32nd of an inch. Okay? So, let me generate the tool path and show you what it does. As you can see, the tool path is going to start up here and work its way into the line that you drew. That's how this is orientated. Now if I switched this from outside to inside and regenerate the tool path, you'll notice it's now going to come up in this direction. So it's going to start here and then work its way up towards that line. That's not how I wanted it. I wanted it to conventionally cut. I set this thing up to conventionally cut. So let me regenerate the tool path and generate it. Okay, so what it's going to basically do is go from my home position out to here, and then it's going to conventionally cut, then come back to the next line and conventionally cut in this direction, the same direction that you drew your line in. In this case I drew it from right to left. Now if I had drawn it from left to right, it would be climb milling. It would come up here and it would cut in this direction from left to right, and then come back and then cut again from left to right. Okay, so I'll show you the difference real quick in NC Corrector between climb and conventional cutting on this, how this works. Since I drew the line from right to left, okay, the way this is going to mill is like this, from right to left, and each cut is a conventional cut. Okay, so if I go ahead and step through the program, it's going to jump off up to my clearance, it's going to wrap it over, and then plunge outside of the box. Okay, I'm plunging just only into the air. I'm not plunging down on my part. Okay, that's why I drew that little circle for the diameter tool, just to show you that. Then it's going to proceed with a cut. It's going to enter the part in a milling fashion, not plunging, milling side from side. Okay, then it's going to mill this conventionally, step up off the part, come back, plunge down, not into the part but off the part, and then it's going to proceed with another milling cut, which is conventional. Okay, then it's going to come up and back, come down and cut, come up and back and come and keep. It's just going to keep repeating this. This is what you call a facing operation. Okay, I'm going to face the part off. Now, had I gone and with the other method, if I drew the line from left to right down here, this is what it would do. It would be climb milling. Okay, just so you're aware of that. And when you do that, you got to flip that inside outside thing around the other way. It has a little button on there for conventional and mixed and climb that has no bearing on this because it's an open chain. It's just a single entity. Okay, and keep in mind you can reverse these things, and you got to know the orientation of them, so the way in which you draw them, it matters on the way the toolpath is going to project. So in this case, let's for instance say that I drew the line from left to right and I did all the parameters the same. Okay, what it would do is, obviously it's going to jump off the part to my clearance, and I don't want it to touch my part, so I'll put like a piece of paper or something in between there. I just want it to be off the part. Okay, then it's going to go ahead and plunge, but it's not going to plunge into the part. It's going to plunge outside the part. Important to keep that in mind. Okay, you don't want to be plunging a big tool into the part. You want that to plunge outside the part. All right, then it's going to proceed to cut with a climb mill style. Then it's going to jump up to my clearance, go back, wrap it back, jump down off the part, and then do another cut. And it's going to jump up, back, wrap it back, down, and do another climb cut. It's climb milling right here, okay, in this direction. Alright, and it's just going to proceed to keep doing that and climb completely across the part, facing it off. That's a facing operation. That's how you program it in Kanban. It's a really simple thing to do. The reason why I drew this out for you is because I wanted you to understand the meaning of having this come off the part, because now when you come from your home position to here, you want to make sure that this cutter tool is off the part, not plunging down into the part. Okay, it's very important that you keep that in mind. You do not want to plunge a big fat mill. This is 1.25 inches. You probably could, all right, but you know, I've seen facing mills, you know, that get big, 3 inches, 4 inches. You definitely don't want to plunge a mill like that directly into the part. You want it to come off the part and then face across it and mill across it. Okay, now one quick little thing in Kanban that I want to show you. Now if you select up here, you can select your profile cut, your machining operations, or this whole entire machining thing. If I change this over here where it shows cut width, let me just bring this out just a little bit. If I like double click on that to make it go from false to true, now when I hit this, you'll see the cut width. Okay, so this is just like I was showing you the width of this diameter, just so I drew that little thing so you could see. Now this shows you the cut width, your actual cut width. So it's like, it's kind of like you're verifying how much material you're removing, because it shows you the diameter of the tool, not just the tool path itself, not just, you know, the actual center line of the tool path. It's showing you the diameter, so which is useful information. You want to keep that in mind to do that. So that's about it as far as facing is concerned. You do want to watch yourself with facing when you're facing parts off. You do want to not plunge. I can't stress this any more than I already have. A big fat mill, you don't want to plunge it directly into your part. And when you're and you want to be careful that when you're starting your milling operation, if you get the balls to go ahead and start it right here in the middle of this thing, you might consider changing your home position so you start it off the part as well. But I felt safe in this instance that it wasn't going to contact anything. But you may want to space it up off the part just a little bit, just so it's not touching the part, you know, so you're safe. Because the bigger the mill, the more dangerous it's gonna get. Okay, just keep that in mind. It's just more mass that's moving there. Okay. So that's about it with the facing. It's a pretty easy thing to program. Like I said, it's just a line. It all depends on how you have it orientated. And that's about it, you know. You just let me show you this. This is the interesting thing that you might want to consider. This cut width thing, let's say I turn that to 5 inches, okay, and generate the tool path. You see, I'm not going to be facing this part of the part. Okay, so you want to just make sure your measurements are right. If I put it on 6 inches and generate, I am, but I'm going to come in at a pretty high percentage of the tool that's going to cut, and I really kind of only want it to cut at 40%, so I made it like 6 1/4. Alright, so I can engage a little less material on my first cut. You see what I'm saying? So if I turn this off, it'll show you the center line of the tool. Right. So I didn't want to engage like that much on it. Alright, so yeah, you can set that up how you like. It's not that hard to do, but it is an important first step to leveling your part. It's basically where it all begins, is where you would start with, is your initial leveling. And I mean, climb cutting that in that direction depends on how you draw the line. Conventional milling, I cut this part with a conventional cut. Alright, I wanted to give that a try to see how there's advantages to both. Conventional and climb milling both have their advantages. There's a lot to learn online about that. It's pretty basic stuff. So yeah, that's the basic facing operation. And if you take a look from the side, you can see how this tool path is running. You look at it from this angle, see how that's going to run. Alright, it's a simple path, but you don't want to get into trouble with it. With a bigger bit, you can get into trouble. So you want to be careful with it. Alright, I just wanted to briefly talk about my layout over here. Now, as you can see, we're back into double CAD with this, and I basically drew up a quick layout of my table here, and I have this all on layers. I imported that file so you could see it, but here's my table. I have a couple clamps on the table. This is a stop piece and that's a clamp. These are my machining extents. So this is like the maximum travel of the machine. But you got to take into account the bit. So let's say this cursor is a bit, like you know, a 3/8 or a 1/2 inch bit or whatever it happens to be. If it's in a 1 inch bit, obviously I'm going to be able to cut around that by the radius, so I'll be able to cut a 1/2 inch around my travel extent. So you have to add things up when you're dealing with that. Okay, travel extent is based on the DRO of the machine, as well as this table. On this layer I have the table itself with the T slots. That's all based off the DRO of the machine, the digital readout. And my home position, this is my mechanical home position, which goes off the switches. You'll notice that it's got a slight offset to it. That's because of the way the router is mounted on that thing. So I've imported our file, and I'll just go ahead and select that right now and drag that to the table. And I do this quite often just to see how I'm going to lay this out on the table, just to see how it's going to fit, if I got enough room for clamps, stuff like that. Okay, it's something you may want to consider, is doing yourself a favor and drawing out your table. And I just went with the DRO on that. I think it's accurate enough of a drawing to yeah. And then I can take my parts, and you know, if I have to lay them out with if you know, I got to be able to machine this. I can see how many pieces I can fit on the table at a time, and what orientation I may have to. Let's say if I have to rotate. I'm rotating in 3D there. I guess I got to switch this, toggle it to 2D. So you know, if let's say I had to rotate something around, I'm just, you know, playing around here, and just to fit multiple parts on the table or something like that. So it's a good idea. I could always undo things in this program, so that's, you know, it's just a good idea and a helpful tool to let me know, you know, what the workspace is, what my work envelope is, how I'm going to fit things around here. And if I had a sub base for this, how would I, you know, what would I use for fixturing and so forth and so on. Okay, so that's basically that. Okay, so wrapping it up here. It's getting pretty long, isn't it? But yeah, I know. We're back in Camodics here. We want to verify everything, okay? So we'll go File, New Project. So we'll just add in our G-code files. And there's only like, what, 3 of them that we got to add in? We don't need to add in the facing program. That's just unnecessary. Because I'll be cutting that differently anyway on the machine. So I'll just go ahead and add my G-code file, clean one, add another one, clean 2, and our third and final masterpiece of a toolpath, wasn't it? Add file, G-code file, Tiger. Alright, so now we're all situated. Now all I got to do is add tools. So I'm going to right click on this. Well, first I want to check that I actually have a tool in all of these, because I'm not sure if I do. No, I don't. So I'm going to have to revise the code. This is really easily accomplished. I'm going to put I'm going to put a T1 space M6 into clean 1. Alright, close that and save it. Into clean 2, I'm going to put a happy space to put T1 space M6. Okay, T1 just tells me that it's tool number 1. The M6 is that it's assigning a tool change to the program. I believe that's what it is. Don't quote me on that. But here we have our program written with CAMBAM, and we have a T0. This writes it backwards, MO6 and T0. But I want a T2 over there, so I'm just going to modify that, put a T2 over there. Boom, done. And save that. The only reason why I'm doing this is for verification purposes only. I don't care about how it's going to wind up on my controller. I do manual tool change anyway, so if I had an automatic tool changer, then yeah, I would want a tool library and all that. But you can have a tool library in this program, which is nice. So all your tools, I suggest you create a library and just name them tool 1, 2, 3, 4, 5. I only use a few tools that I need. So, and then you can import your tool table. In this case, I'm just going to go ahead and create the tools right now. I'm just going to go new tool, and that's going to be number 1. It's in inches. It's a flat tool, and it's going to be 1/4 of an inch. Okay, 10 inches is a little big for that. I'll make it 1 inch. Alright, save it. Tool number 2, new tool. Tool number 2 is going to be our ball tool, our ball nose tool, and remember that's 1/8 of an inch. Okay, boom. So now we can go ahead and generate, but before I do, I'm just going to turn my settings up to very high so you can get a nice clean, crisp picture of what's going on here. So I'll generate, let it do its thing. So there's our ramping into the part as we've done, and then it's going to change tools and then cut with that ball mill. Alright, I have the workpiece set on automatic. There we go. If I shut off the tool path, shut the tool off, shut the axes off, we know where the axes are by now, at least I hope you know. So there you go, and this is what the final outcome is supposed to look like. Alright, now what's interesting about this program is, let me turn the tool path back on, and I'll turn the tool back on so you can see how the tool changes as well. If I back this up, on this slider on the bottom, I could take this all away and just, here's our roughing, notice the size of the tool, it's a 1/4 inch tool, okay, and then it changes tools right around there. After this tool, see how it just changed right there? Alright, the next step will be the tool change, which I believe is the M6. So I'm going to leave it right there. If I leave it back in that position and regenerate this, watch what happens. This is a pretty neat trick. I don't know if you know this, but it's kind of a neat thing that I just discovered myself. And let that generate. But now you can see what just happened there. It didn't include the second tool path because we stopped it right in this area. Okay, now I'll go ahead and run it like halfway through, and so we're just looking, we're just kind of looking at what would happen between tool changes right there. So I find that to be of interest, and maybe you do too, because I wasn't aware that the program was even capable of that, but it's definitely a useful feature. So Now, it doesn't actually show the milling happening itself. It is very useful to be able to stop the toolpath, like, okay, we'll do this whole, check out that ramping feature, folks. I'm really kind of proud of being able to code that just by hand. So it's going to run that course, and then it's going to change tools, okay, and then I'll just cut like halfway through the tiger. So I could close this so you can just view the toolpath. So I can pick as much of this toolpath or as little of it as I choose. Okay, so let's let it run to about the nose of this tiger, just to see, and then we'll regenerate it at that point. And I have this set on very high, so it's obviously taken a little bit of computing power, but it's not really that too bad. I probably should have set it to low just to quicken things up a little bit. But if I turn that back on now, and I'll turn the toolpath off, you'll see a very kind of a cool thing. You can see that only part of this thing got machined. It left off where I placed it. So that's kind of a little neat trick that I kind of just figured out myself. I thought I'd share that with you. Alright. Now when it comes to, so you want to fast forward this thing all the way if you want to do it. Now when it comes to setting this up for manual stock, since our stock is dead center, our home rather, and turn the axis on, that's our home position. It's going to be dead center of our stock. So our dimensions are right over here, okay, in the Y dimensions. We decided on like 5.5 inches, okay. Your offset is going to be negative half of that, okay. So it's I think it's like minus 2.75. All right. In the X direction, I finally decided I'm going to use a piece, and I have it on the table right now. It's 3 3/4 inches. So I'm going with the 3.75 inch stock. All right. Let's whip out the calculator and figure out what that number is divided by 2. So 3.75 divided by 2, 1.875. Okay, so that's my offset, right? And it's a negative number, minus 1.875. I don't know why it won't. It's not good to pass 2 decimal places on that, apparently. This thing likes metrics, so. And then in my Z direction, I'm just gonna, it's a piece of 2x4 type style wood, so it's like, it starts off with 1.5 inches, but I'm just gonna say it's 1 inch. Okay, let's just say for the sake of it, it's 1 inch. And then you want to put a negative number of 1 inch in the Z direction. So you don't divide that number by 2 like you did with your X and your Y, because this thing is going to get a little confusing on you, but if you play around with it enough, you'll figure it out. So, but I wanted the manual dimensions to be as it's actually going to be. So I'll regenerate the toolpath just for you right now so you can see what I'm talking about, okay? And keep in mind that the Z is not going to be accurate, because it's probably going to be a little bit more than that. So there we have it. The final product, I guess you could call it. And you will notice that we do have a little bit of an area here that has not been machined. Unfortunately, yeah. But that's not a big deal to manually clip off of there. That's easy enough to fix. But we have perfect alignment as far as coming around this thing. Okay, you can see there's a clearly defined edge around the whole thing of it that we're milling out with that 1/4 inch bit coming into it first. Alright, now you may have noticed that area of the chin, I let go a couple of those straight cuts. No big deal, I don't think. Yeah, so this is what you want to do. You want to check your part. Now we could go ahead and fix this. I'm not going to. I'm just going to leave it on there and cut it off on the mill manually. It's a paper thin piece of remaining stock, and it'll probably get blown out of there anyway just by air pressure. Okay, but yeah, so the next step is basically to machine this thing. Alright, and get her done already. It looks pretty cool, and I think it came out nice. I like it. I think we did a good job. Give yourself a pat on the back for that one. Alrighty. Take care.